Good morning, guys. Welcome back. It is an exciting new topic that we're going to be starting today with organic molecules. So, this is probably one of the more complex topics in terms of there are a lot of little details that you have to remember. Other than that, once you've remembered it, there's a very clear set of rules. If you always follow the rules, you will always get the correct answer. Pretty much. So we're going to start today with organic molecules. We're going to go into the basics. What are they? And then the most basic naming, because that's what we're going to be focusing on at the moment, naming these organic molecules. From that point, we'll then go over the next couple of lessons into the more complex structures and things that can come off of the structures and stuff like that. So that gets a little bit more complex. But for this start, it should be fairly simple, hopefully. So the first thing you need to know is that an organic molecule is usually made up of hydrocarbons, which is just a molecule that contains hydrogen and carbons. It can contain other things as well, but for the most part, they will have a lot of hydrogens and carbons and then other stuff added on top of that. You will often also find oxygen in there, and then you've got some others, nitrogen and sulfur sometimes, that can come in as well. But that's pretty much what an organic molecule is. It's made up of a hydrocarbon and other stuff. And they can get quite complex. And so they've got this whole naming system that is consistent across all of the countries in the world. Everybody that does chemistry follows the same naming system for these molecules. So a lot of them have normal, real-life, everyday names, as well as a scientific name, which we call IUPAC naming, which I think stands for the International Union of something in Applied Chemistry. I don't remember what it stands for. It stands for something probably really important, but it's essentially just a set system of naming that is used for naming all molecules from everybody in the world. And then normal people that aren't scientists have the everyday naming, which you'd know them by at this stage. So this is an example of some of the types of organic molecules you can find in this picture. So we've got things like natural gases like methane, crude oil, which contains a bunch of different organic molecules. You can see that the carbon is in grey and the hydrogen is in blue, so there's a lot of carbons and hydrogens. And then, as I said, you throw in some oxygen, nitrogen and sulfur, and then you've got a huge range of different shapes that you can get, which you can see in the kind of crude oil section. Some of them look really, really cool and would be very, very complex to name. We are not going to be naming anything that crazy, but some of this you'll be able to name by the end of today, hopefully. So the first thing we need to know, the main thing that you'll find as a hydrocarbon is an alkane. So an alkane is just a hydrocarbon that only has single bonded carbons and hydrogens. So the whole main chain is just made up of carbons that are attached to each other, and each of those carbons will have a certain number of hydrogens coming off of it based on what else it's bonded with. You should know at this point, hopefully, that each carbon can have up to 4 bonds. So if it is a carbon by itself, it is going to have 4 hydrogens attached. If there are 2 carbons attached to it, so 1 on each side, then there's going to only be 2 hydrogens, 1 on the top, 1 on the bottom. Hopefully that makes sense. So these are named using prefixes and suffixes, as is you're going to find out a lot about prefixes and suffixes in organic chemistry. But for alkanes, it's pretty easy. The end of the name is always going to end in ane, so it's an ane. Alkane makes sense. Sometimes you'll add other things on the back of that suffix, and in that case you get rid of the e and it'll be an and then whatever else you add. So there's always going to be the an part if it is an alkane as the main chain. The prefix depends on how many carbons. So this is where we're going to start to get into the first thing that you have to really start remembering. So the prefixes are on the side here in this table. So the number of carbon matches with the prefix. They're all alkanes, so they all have the same suffix, which is the ane, and then the different structural form you usually can look at. So if the main carbon chain in a molecule has 1 carbon, then it is called a meth something. So in the case of an alkane, all of them, it's going to be methane. You've all heard of that before, hopefully. 2 carbons is eth, so ethane. 3 carbons is prop, so propane. 4 carbons is butane. 5 carbons is pentane. 6 carbons hexane. 7 carbons heptane. 8 carbons octane. And then I also have on the side here a hydrocarbon chain containing 9 carbons is a nonane, and 10 carbons is a decane. So you don't really need to know at this stage past that. And if you do need to know it, you will be told what the prefix is for that number of carbons if it's like a challenge question or something. Looking at the structural formulas here, this is how I typically tend to draw the alkanes and just organic molecules in general. There are a lot of different ways, and you will see a lot of them over the next couple of weeks. This is the main way, but it takes a lot of time and a lot of effort, and a lot of people don't like having to write lots of little H's. So you may also see it with just the dashes and no H's, or you may see it as just a little bunch of lines. So when we get to those, I'll try and explain what they mean, but for the most part, you will see it like the structural formulas here, where you have the carbons in the middle that are connected by the lines, which are the bonds, in this case single bonds. If there was 2 lines, then it would be double bonds. And yeah, so that's over here, this stuff. And then the molecular formula is just telling you overall how much of it you've got. So you've got 1 carbon, 4 hydrogens, 1 carbon, 4 hydrogens. Makes sense, right? I hope so. So what you have to do on this slide, if you have not done it already, is copy down the table into a book or onto a piece of paper, or make it a poster, or whatever you want to do, and add the information that is up here for the 9 carbons and 10 carbons. So that should be pretty easy, and we are going to do some practice naming. So this is pretty easy. The first thing we need to do is work out, well, firstly, how many carbons do we have? So we've got 1, 2, 3, 4. Wow, I'm really bad at writing stuff. That's fine. So 4 carbons, which means we're going to have, oh my goodness, this is bad. But as our prefix, and then its suffix, because it's only single bonds, is going to be ane. So it is a butane. It's super exciting, super easy. And then this one, we've got 1, 2, 3, 4, and 5, and 6. So 6 carbons means our prefix is going to be hex, which means that if we only have single bonds, which we do, then it's going to be hexane. There we go. So those are very badly written. I'm sorry about that, but hopefully that makes sense. So you count the number of carbons. Once you've got the number of carbons, then you go back to your prefix table and match it up, and then that's what it is. Hopefully that makes sense. So the next thing we're going to be talking about is you will never, okay, that's like, sometimes you'll find this, but it's very unlikely that you'll find just a single chain of just carbons and hydrogens. So usually, as things start to get more complex, you get chains that come off of the main chain. So that's called secondary chains, or at least I call it secondary chains. And there are some organic molecules that have multiple chains. The main chain is the longest continuous chain. So no matter what way you look at it, which one has the longest amount of carbons directly attached to each other, that's the main chain. That's the one that you name first, and you have to understand the main name for that first. Once you've done that, anything that comes off of that chain, like this box that I've got up here, I need my laser pointer again, like this box that is up here, that is the secondary chain. That's a secondary functional group. So that needs to be named separately and attached to the name that you've already got, if that makes sense. So if we have a look at this top part, if we ignore the box for the moment, this is a 4 carbon molecule. So it is going to be a butane because it's only got single bonds. So but for the prefix, ane for the alkane part. And then we've got this one coming off of the bottom. So what we do with that is we name it separately by itself. So it's got 1 carbon in it. So it's going to be a meth group. That's going to be our prefix for it. For the secondary chains coming off of it, instead of using the ane as well, we add a YL on the end because it's technically called an alkyl group. So in this case, the functional group, I spelled therefore wrong. Oh well, the functional group is going to be called a methyl group, because there's one carbon in it and it's an alkane coming off of the main chain. I hope that makes sense. I think the more you do this, the more it makes sense. But that's kind of the rule. If there's secondary chain made up of only carbons and hydrogens coming off, you use the same prefixes as normal alkane naming systems, and you add the YL on the end. And then you put that whole name in front of the main chain. So the main chain is a butane. We have one methyl group coming off, but we need to write down where that is, because currently a methyl butane could be a methyl attached to either of these two carbons at the top or the bottom or the side. Like, we don't know that yet. So we need to be able to communicate that to other people. If we're naming molecules, or we're discovering or creating molecules, and we're trying to put that across to the rest of the scientific community, we need to very clearly be able to show them exactly what our molecule looks like and how it fits together. Now, this is a very bad example because there's only one place really that this can go, but we're going to go with it anyway. So the last thing you need to do when you're naming your system is you need to go through and work out, okay, where is it? So where is that group coming off? So the way that we do that is we have to number the carbons in the main chain. So you can do this either backwards or forwards. So I have over here, the blue is going forwards and the red is going backwards. The way that you pick which one is correct is whichever one has the lowest number that is attached to the functional group is the one you use. So that can get a little bit complex when you have multiple functional groups. So if we had 4 or 5 functional groups, then you'd have to pick the one that makes it so each of those is at the lowest point possible, if that makes sense. That's just a general convention. Either way, it would typically work, I guess. Yeah, you'd still end up with the same answer, but it looks weird when you do it differently. So pick the one that's got the lowest number, which in this case is 2 instead of 3. So it is going to be a 2 hyphen methyl butane. So that just, the 2 hyphen means that at carbon number 2, there is a methyl group on a butane. Hopefully that all makes sense. So we're going to go through 2 examples now. I have them on the board. If you want to, you can go through and give them a go before you go through it and try and work it out yourself. We are going to go through the steps that I kind of go through a little bit in my head on the screen. So hopefully you'll be able to see that. And then we'll later on go for some more examples. But for the moment, we're going to try this. So the first thing we need to do is find the main chain and then circle any of the secondary groups. So the main chain is 5 carbons and there is 1 secondary group at the top. And then pick which numbering system is the correct one. So again, it is the blue going from left to right. Then you name the main chain. So there's 5 carbons, which means it's a pent group. They're all single bonds, which means it's an alkane, so pentane. Fairly simple. And then we name the functional group. So the functional group has 1 carbon, which makes it a meth group, and it is an alkane, makes it a methyl group. And then that is off of carbon number 2. So when we combine all of that together, we end up with 2 methyl pentanes. So fairly simple, fairly similar to the last one. But this particular problem does illustrate kind of the difference. So you can have your methyl group come off here. If you didn't put the locator and you gave that to 5 or 6 different people to try and draw, you might have one person put it here and one person put it here and one person put it here. So it's very important that you have that locator on there for things that have multiple places they can possibly go, so that you and every single other person that looks at that name will get the exact same answer. Hopefully that makes sense. All right, let's go on to the next one. This one is a lot longer. So again, we have to find the main chain. So if we count from this way and this way, like we've been doing, we've got our red and our blue again. We've got to be careful because sometimes the secondary chains, the ones that look most like the secondary chains, could actually be a part of the main chain. So in this case it's not, but it could be sometimes, particularly this one. We could go 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. They're both the same. But if there was another one up here, another carbon attached to here instead of the hydrogen, then the main chain would be 1, 2, 3, 4, 5, 6, and it would be a 6 carbon chain instead of 5. So you've got to be careful. Sometimes it looks like it's going to be a secondary chain, but it is actually a part of the main chain, and then something else is the secondary chain. Hopefully that makes sense and doesn't confuse you. All right, continuing. Number the carbons left to right or right to left. And again, the blue numbers is correct because it's a 4 instead of a 6. Name the main chain. So there's 9 carbons and the prefix for 9 is non, so it's a non-ane because it's an alkane. Name the functional group. This time we have 2 carbons inside the secondary group, and that means it's an ethyl group, and then it is off of number 4, so it is going to be a 4-ethyl nonane. Hopefully that makes sense. I did want to also point out here, this is an example of another type that people draw. So there is no there's no hydrogens drawn on this molecule at all. However, you have to have the understanding that each of these carbons is going to be attached to 4 things. So if it's only showing 1 bond with a carbon, that means there's going to be 3 hydrogen bonds coming off of it, even though it's not represented in this diagram. They are still there, just sometimes scientists are a little bit lazy. All right, this is the last thing that you kind of really need to wrap your head around in this PowerPoint, I guess. If there is more than one secondary chain, like this one and this one right here, we have 2 of the same type of chain. We then need to use a different set of prefixes that represents how many of something you have. Now, you've seen these before when we've been naming chemical formulas. So dihydrogen monoxide, carbon dioxide, hydrogen trisulfate. I don't know. I don't remember what one with tri or tetra is. But you've seen these before. They are just the basic naming. So di, tri, tetra, penta. So di meaning 2, tri meaning 3, tetra meaning 4, penta meaning 5. You're likely to get a lot of 2s and 3s and then not many 4s and 5s. So as long as you can remember the gist of it, you should be fine. So it works exactly the same way. So start the same thing. Find the main chain, circle the secondary groups, number the carbons. I didn't put in 2 numbering systems, so whoops, but it's the blue ones again. So 1, 2, 3, 4, 5. And you can see if you went from this direction, 1, 2, 3, 4, 5, the 3 would still be the same, but then it would be on 3 and 4 instead of 2 and 3. So we picked the blue ones because 2 and 3 is lower than 3 and 4. Hopefully that makes sense. 5 carbons, meaning it is a pentane. Now we name the functional groups, all of them. So in this case there are 2 and they're both methyl groups because they both have 1 carbon. And then we find the locator. So 1 is off 2 and 1 is off 3. And then when we add it together, we just combine those numbers. So 2, 3 dimethylpentane. So for every single secondary chain or functional group that you have on an organic molecule, you need to have a number, unless it is the only possible place it could go, which there are a few that will do that eventually, but at this stage, you should not be having any name that doesn't have a number in it. Hopefully that makes sense. So in this case, because there are 2 groups, we're going to put the 2 numbers, so 2, 3. If this group here was, instead of being attached to carbon 3, was also attached to carbon 2, so you had the top and the bottom, you still need to put 2 numbers in. Even though they're both off of carbon number 2, you still need to put both numbers in to represent that they both are there. So in that case, if this was over here off carbon number 2, it would be 2,2-dimethylpentane. Hopefully that makes sense. All right, and then if they are different secondary chains, so in this case we've got 1 methyl group and 1 ethyl group, we put them in alphabetical order. So it doesn't matter the priority of the groups, it doesn't matter which one's more important or which one's better or which one's longer, it just goes in alphabetical order. So basic A, B, C, D, E, F, G. Hopefully you know the alphabet by this stage, but if not, I'm sure you can Google search it. So same steps as before. Find the main chain, circle the groups. Number the carbons in the main chain, so 1, 2, 3, 4, 5, 6, 7. Name the main chain, so 7 carbons means it's a hept prefix. It is still an alkane, there's still only single bonds, so it's an ane, so heptane. Makes sense. Next, name the functional group. So we've got 1 methyl group and 1 ethyl group. Very simple. Find the locators, so 2 and 4. And then combine in alphabetical order, which means the ethyl is going to come first. So it is 4-ethyl 2-methylheptane. Now, this may seem strange because usually, typically, or at least in my mind, it's strange to me because I would usually typically put things in number order first rather than alphabetical order. But the alphabetical order makes much more sense in this case, because when you have multiple different functional groups, multiple different secondary chains, and sometimes you'll have double of a methyl group or double of an ethyl group, and you've got multiple numbers, and so the numbering system, using the locators to order it, wouldn't make as much sense as just ordering it in terms of the actual alphabetical order. Also, if you say did have, I don't know, 2 of the methyl groups, so if you had another one coming off of somewhere and it becomes a dimethyl group, it still would be in this order because it's the alphabetical order of the functional group names, not the amount of them that there are. So it would still be 4-ethyl 2,2-dimethylheptane if there was another methyl group coming off of here. It would still be in that order. Even though D is in front of E, we go off the M, not the D. I hope that makes sense. It will make more sense as you continue going through it and you do it and you have examples happening. So hopefully it all is coming together for you. The last slide is some practice slides. So what I'm going to do is pause the video here, give this a go, try out these 4, and then I'm going to make a separate video where I show you these 4, how I do the steps for this, and I work through it and write down the answers. So if you need to look at the answers or want to look at the answers or get stuck, go and check out that video. Otherwise, give them a go yourself, and hopefully you've got it all down. So fingers crossed. There will be another video up about alkenes and alkynes, which are the next things we need to learn, which are the doubles and triple bonds. And then after that, it gets a lot more complex. So if you don't have this down, if you can't do these 4 and you're getting stuck, you need to go and work out why, and you need to ask those questions, because it only gets more complex from here. Hopefully that all makes sense. Hopefully I didn't overload you with that, but I shall see you guys in the next video. Hope you enjoyed. Thanks. Bye.